Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve the questions from network analysis of EC, EEE and GATE examinations. Friends, to solve numerical examples, it is essential to analyze the given data to find the unknowns. Based on the given data, we are required to choose the appropriate equations to arrive at the results easily. Therefore, here are some brief procedures to derive the equations, and derived equations are also listed for your ready reference. Remember, while solving the network, you can choose the appropriate equations straight away and use them unless it is asked to derive. Friends, here are the links of videos on series resonance circuit where all the equations are derived. I suggest it is better to watch the previous tutorial videos so that you can understand the solutions very easily. Friends, first let us solve question 1, wherein we are required to find the resonant frequency omega naught and f naught, current at resonance I naught, Q factor, voltage across L and C at resonance, and bandwidth in radians per second and in hertz. Observe the network. We see that all the circuit elements values are given. So, straight away we can select the equation for omega naught is equal to 1 divided by root LC radians per second, and f naught is equal to omega naught by 2 pi hertz. By substituting the values of L and C and solving, we get omega naught is equal to 5000 radians per second. Using f naught is equal to omega naught by 2 pi and substituting the values of omega naught, we get f naught is equal to 796 hertz. We know that I naught is equal to V divided by R, and substituting the values, we get I naught is equal to 2.4 amperes. Now, we know Q is equal to omega naught L by R. By substituting the values, we get Q is equal to 10. Further, at resonance, VL is equal to Vc is equal to Q times V. By substituting the values, we get VL is equal to Vc is equal to 2400 volts. And bandwidth is equal to omega naught by Q. By substituting the values, we get bandwidth is equal to 50 radians per second. And finally, bandwidth in hertz is equal to f naught by Q. By substituting the values, we get bandwidth is equal to 79.6 hertz. Friends, next we shall solve question 2. It is given that a coil is connected across phi of t is equal to 10 cos 1000 t. The current is maximum when C is equal to 10 microfarads. When C is equal to 12.5 microfarads, the current is 0.707 times the maximum value. We are required to find the values of L, R and Q. Observe that no values of the circuit elements are given, but the applied voltage is V of t is equal to 10 cos 1000 t, from which we get omega is equal to 1000 radians per second. Since frequency is not varying, we can take it as omega naught is equal to 1000 radians per second. If we further look at the given data, we find two statements. The current is maximum when C is equal to 10 microfarads. When C is equal to 12.5 microfarads, the current is 0.707 times the maximum value. What does this mean? When C is equal to 10 microfarads, the current is maximum, meaning the circuit is at resonance at omega naught is equal to 1000 radians per second. So, knowing omega naught and C, using omega naught is equal to 1 divided by root LC radians per second, we can find L. By substituting the values, we get L is equal to 0.1 henries. So, knowing LC and omega naught, we should be able to find XL and XC. Using XL is equal to omega naught L, we get XL is equal to 100 ohm. And XC is equal to 1 upon omega naught C. By substituting the values, we get XC is equal to 80 ohm. Note, resonance frequency remains same, but C has changed to 12.5 microfarads. Hence, R is equal to XL minus XC, and that is equal to 100 minus 80, and we get R is equal to 20 ohm. Once we know R and L, we can find Q using Q is equal to omega naught L by R, and substituting the values, we get Q is equal to 5. It's very simple, isn't it? Friends, to understand the solution better, you must think of two circuits. One when C is equal to 10 microfarads, and the other when C is equal to 12.5 microfarads. Other than the change in capacitor value, the remaining circuit is unchanged. The two circuits are presented here with relevant values indicated as obtained in our solution. When C is equal to 10 microfarads, omega naught is equal to 1000 radians per second, current in the circuit is I naught, which is maximum. When C is equal to 12.5 microfarads and omega naught is equal to 1000 radians per second, the current in the circuit is I naught by root 2. These are the two circuits which are different. This you have to note. Friends, next we shall solve question 3, in which it states, a series RLC circuit has a resonant frequency of 1 kHz and a quality factor of Q is equal to 100. If each R, L and C are doubled from their original value, find the value of nu Q. Friends, by analyzing the given problem, we find that F naught is equal to 1 kHz, Q is equal to 100. The circuit elements are R, L and C. We know that omega naught is equal to 2 pi F naught radians per second. Now, we are required to find, say, Q2 when all the circuit elements values are doubled compared to the original values. Friends, the problem seems to be simple but tricky. I will tell you why. To arrive at the solutions, what immediately strikes to our mind is to recall the equations for Q. We know that Q is equal to omega naught L by R, Q is equal to 1 divided by omega naught CR, and Q is equal to 1 divided by R into root L by C. The next important problem is which equation to be used. Let us explore, friends. If we consider the first equation, we get Q1 is equal to omega naught L divided by R, and this is given as 100. Let new value of Q be Q2, and Q2 is equal to omega naught into 2L divided by 2R, and again Q2 is equal to 100. So, according to this first solution, if you choose option C as the correct answer, friends, you are wrong. I will tell you why during the next discussion. Friends, if we consider the second equation, we get Q1 is equal to 1 divided by omega naught CR and is equal to 100, which is given. Q2 is equal to 1 divided by omega naught into 2C into 2R, and we get Q2 is equal to 1 divided by 4 into bracket 1 divided by omega naught CR, and by solving we get Q2 is equal to 25. According to this solution, if you choose the option A as the correct answer, friends, you are again wrong. I will tell you why. Friends, note that we are required to find Q2 when all the circuit element values are doubled. In solution 1, that equation contains only L and R, C is missing. In solution 2, that equation contains only C and R, L is missing. So, let us use the third equation for finding Q. Friends, if we decide to use third equation, you may get a doubt about omega naught as missing in the equation. I will clarify your doubt. If you recall the derivation of third equation, we started with Q is equal to omega naught L by R. By substituting for omega naught equal to 1 divided by root LC, we obtained Q is equal to 1 divided by R into square root of L by C. It means while deriving this equation, we have taken care of omega naught. So friends, by using third equation, we get Q1 is equal to 1 divided by R into square root of L divided by C and is equal to 100, which is given. Q2 is equal to 1 divided by 2R into square root of 2L by 2C, and by solving we get Q2 is equal to 50. Hence, option B is the correct answer. Friends, you agree that solution is simple but tricky. Hope you will appreciate this explanation. Friends, finally we shall solve question 4. In this question, we are given two circuits. In one circuit, the component values are L1 and C1, whereas in the circuit 2, component values are L2 is equal to L1 by 4 and C2 is equal to 4C1. We are required to find the ratio of bandwidth 1 to bandwidth 2. First, let us find the resonant frequency of both the circuits. We see that omega 1 is equal to omega 2. But bandwidth 1 is equal to R divided by L1 and bandwidth 2 is equal to R divided by L1 by 4, and we get bandwidth 2 is equal to 4 times bandwidth 1. Therefore, the ratio of bandwidth 1 to bandwidth 2 is equal to 1 divided by 4. Hope you understood it. Friends, we have solved a few interesting questions in this tutorial. During the next tutorial, we shall meet with some more interesting problems. Hope this presentation has kindled some of your thoughts. Thank you for watching.